Hello friends, in this video we will solve more problems on number system. Let us begin. Question number 1 is appeared on your screen. It says find the base for the following where 38 plus 43 equal to 80. It is quite sure that 38 plus 43 is not equal to 80 if we assume it is base 10, that is decimal number system, right? So this is something else. Let us try to find. Assume that base is b. In that case, I can write this as 38 to the base b plus 43 to the base b equal to 80 to the base b. Now convert everything into equivalent decimal. So I can rewrite this as 3 into b plus 8 into b, power would be 0 and 1, plus 4 into b plus 3 into b, again power would be 0 and 1. This will be equal to 8 into b plus 0 into b, and of course power would be 0 and 1. Now if you solve this, this would be 3b plus 8 plus 4b plus 3, and this will be equal to 8b. So 3b plus 4b becomes 7b, and if you shift this 7b to right hand side, it would be b equal to 11. And what you were actually looking for, you were looking for a base, therefore the answer is base equal to 11. So the base value you have is 11. Let's move to the next question. Question says 302 having base b, which is when divided by 20 again having base b, is equal to 12.1 again having base b. You have to find the value of b. That is, again we are actually finding the base value. As we have done in the previous sum, again we are going to convert the every number over there in respective decimal. In that case, let's see the numerator first. It would be 3 into b plus 0 into b plus 2 into b. Again powers would be 0, 1, 2. Am I right? Whole divided by. Next number is 20 to the base b. So it would be 2 into b plus again 0 into b, having base as 0. Power as 1 here. Equal to, it is 12.1. Try to understand, when it is 12.1, this would have power as 0, this will have power as 1, and this will have power as minus 1. And therefore 1 into b plus 2 into b, again next is decimal point, replace with plus, it is 1 into b, power is minus 1, 0, 1. Is that right? In this case, it would be 3b square plus, it is 2 divided by, it is 2b, which will be then equal to b plus 2 plus 1 by b. Am I right? Or further you can say it is 3b square plus 2 divided by twice of b, which will be, if you cross multiply at right hand side, it would be b square plus 2b plus 1 whole divided by b. So as you can see, your b gets cancelled. Further if you solve, this would be 3b square plus 2, which will be equal to, you can shift the denominator 2 to right hand side, ultimately it becomes twice of b square plus 4b plus 2. Am I right? As you can see here, 2 gets cancelled. So what is remaining? B square minus 4b equal to 0, or you can say b into b minus 4 equal to 0, or you can say now b equal to 0 or b minus 4 equal to 0, which implies b equal to 4. So now we have two possible values, b equal to 0, b equal to 4. What was b? Come on, b was base. You know the fact, base cannot be 0. So what is the valid value of base? It is 4. So the value of b is 4. And as you can see in the problem also, if the base is 4, the maximum allowed digit is 3. So as you can see in this problem, the maximum allowed digit is 3, and 3 is the maximum digit present in this problem, right? Let's move to the next problem. Next problem is appeared on your screen. It says roots of x square minus 11x plus 22 equal to 0 are 3 and 6. Find the base. x square minus 11x plus 22 equal to 0. It is nothing but a quadratic equation. After solving this quadratic equation, you have two roots, that is 3 and 6. You have to find the base. Let's see what we can do with this. X square minus 11x plus 22 equal to 0 can be compared with standard equation, which is ax square plus bx plus c equal to 0. Is that right? So by comparison, you will see a is equal to 1, b is equal to minus 11, and c is equal to 22. So this is the quadratic equation. In quadratic equation, if we have values as x1 and x2, then by property, product of roots is always equal to c by a. So by property, product of roots of quadratic equation, which is always equal to c by a. Is that right? In this case, as you can see, product of roots can be taken as 3 into 6. And this is equal to c by a. What is the value of c? It is 22. And what is the value of a? It is 1. Now the fact is, we really don't know what is the base. Let us assume the base as b. So we can assume this is having base b. This is also having base b. This is also having base b. Even this number is also having base b. Let's try to get this by previous sums. In previous sums, we used to had such expression and we used to find b. Now it is very easy for us. Let's convert this into decimal number now. So of course, after comparison, you'll get this 3 to the base b as 3 to the base 10, 6 to the base 10, which will be equal to 2b plus 2. Of course, divided by 1. But then it has got no meaning. It means it gives you 18 equal to 2b plus 2. Then if you solve, you'll get b value as 8. So they were asking us the value of base, and the base value is what? 8. Let's move to the next problem. 55 to the base b divided by 5 to the base b is equal to 11 to the base b, and find the value of b. It's my experience whenever I ask this problem to students is, sir, naturally the base is 10. But wait, let's try to solve it by conventional method and then we will come to the conclusion. Alright? So convert the given expression, that is whole expression, into respective decimal. So I can rewrite this as 5 into b plus 5 divided by 5, which will be equal to b plus 1. So this will be equal to 5b plus 5, which will be 5b plus 5. You can see this equation. You have to find the value of b, right? What I see, that if I put any value of b here, it is going to satisfy this relation, right? So the value of b is that which satisfies the equation. But then here b can be anything, right? But then let us see the problem. The problem is having 55 divided by 5 equal to 11. See what is the maximum digit that you see over there, right? It is 5. To accommodate 5, what should be the minimum value of b? Of course, minimum value of b should be 6. It means we can say that b can have any value which is greater than or equal to 6. Let me tell you once again, this equation gets satisfied by every value of b. Even if you put b equal to 0, it is going to satisfy this relation. But we know the fact base cannot be 0. Even if you put b equal to 1, it is going to satisfy this relation. But then it is quite immaterial to go for b equal to 1. B cannot be 1. How can we accommodate 5? 5 can be accommodated only by having base at least 6. So the valid answer is base can have any value, but it should be at least 6. So base is greater than or equal to 6 is the correct answer. Let's move to the next problem. 32.3 having base 4 plus 23.2 having base 4. What is the answer? Of course, answer has to be stated having base 4 only. Let's solve this problem. 32.3 plus 23.2. Now here, this 3 was having base as 4. Again, this 2 is having base as 4. We know we are quite comfortable to have addition, subtraction, multiplications or division when it comes to decimal, right? So why not to convert this into decimal? So of course it would be 3 to the base 10 and 2 will be 2 to the base 10. Please remember, when there is a one digit, it can be written as it is as a decimal number, right? So let us add them. 3 plus 2 becomes 5 to the base 10. But what I want ultimately answer, it's something which will have base as 4, right? Then how do we go from decimal number system to any other number system? I'm sure you must have seen the previous videos where what we can have, since the destination base is 4, we can have successive divisions with the help of 4. So 4 ones are 4, remainder would be 1. Then 4 zeros are 0, remainder is again 1. Going into reverse order, 11. So 11 to the base 4 is equivalent of 5 to the base 10. So of course I cannot write 11 here, but what I can do is I can write 1 here and I can set carry as 1. Am I right? Now see, what is the next addition you have to carry out is 1 plus 2 plus 3, but all of them were having base as 4. Am I right? Convert this into decimal. 1 to the base 10, 2 to the base 10, and of course 3 to the base 10. And if I add them, you'll get 6 to the base 10. But what you want, something which is having base as 4. Again, 6 divided by 4 would be 4 ones are 4, remainder would be 2. 4 zeros are 0, remainder will be 1. Here we stop, we collect them into reverse order. What you get is 12. So 6 to the base 10 can be written as 12 to the base 4. But of course I cannot write 12 here, but at least I can write 2 here, and this would be 1. Now we don't have to really do this again, because in the previous addition we have done 1 plus 2 plus 3. Now we are going to add 1 plus 3 plus 2. Irrespective in which base we are adding, it is going to satisfy this commutative law. Therefore 1 plus 2 plus 3, if it is 12, then 1 plus 3 plus 2 would be also 12. So 122.1 to the base 4 is the final answer. Is that right? But I would suggest you a quite easier method now. How come? Just concentrate. You can see that this arithmetic is having base equal to 4. Base equal to 4 means how this number system really goes. It goes like this. We can write 0, we can write 1, we can write 2, we can write at the most 3. No other symbol other than 3 or 0, 1, 2, 3 is allowed, right? Because base is having 4 as value. So after 3, what I can write is only 10, because 4, 5, 6, 7, 8, 9 are not a part of this dictionary, right? 10 is allowed because 10 is made up of 1 and 0. After 10, what I can write is 11, then I can write 12, I can write 13, but after 13 I cannot write 14 because presence of 4, 5, 6, 7, 8, 9. So what I can write after 13 is 20 and so on. Am I right? Let's see what I can do now. I'll write that sum again, 32.3 plus 23.2. All of them were having base as 4. So when you have to add 3 plus 2, then can I say that 3 plus 2 means moving 2 places ahead of 3. Now target this 3. You have to add 3 plus 2. So to add 2, just move 2 places ahead of 3. That is 1 and 2. What you are coming across, it is 11. Means 3 plus 2 is 11. Carry would be 1. Is it? Next is 1 plus 2 plus 3. Now 1 plus 2 means move ahead 2 places of 1. So 1 plus 2 means move 2 places ahead. So after 1, if you move 2 places ahead, you get 3. Am I right? Now 1 plus 2, after that you have to add 3 also. Once now you are present at 3, you have to move 3 places more. So 1, 2 and 3, what number you get is 12. So write 2 again and again carry 1. So 1 plus 2 plus 3, if it is 12, then 1 plus 3 plus 2 would be also 12. As you can see, within a minute I could solve this problem, right? So I have explained you traditional method also, and I have explained you a shortcut method also. Even both the methods you should be comfortable with. because in the next sum we require only method 1. Method 2 would not be applicable in the next sum. Let's see the last problem. So the question is a3 hex minus 6b hex is equal to what? Base hex means it is base 16. So the question is like this. It is a3 having base 16 minus 6b having base 16. Of course answer should be in terms of base 16 only, right? Now we cannot subtract b from 3 because a b is a bigger number as compared to 3. So we replace 3 with 13 traditionally. So we do 13 minus b subtraction first, and of course since we have taken borrow from here, we should replace a with a lesser number, just one lesser than a, which is 9. Let's perform this. First I want 13 to the base 16 minus b to the base 16 as a subtraction. Since we are not comfortable with hexadecimal subtraction but we are quite comfortable in decimal subtraction, why not to convert this into decimal subtraction? Like, first of all, I'll get decimal equivalent for this by doing 1 into 16 plus 3 into 16 power 0 power 1 here. What I get is 19 to the base 10. And b to the base 16 can be written directly as 11 to the base 10. So I can take this as minus 11 to the base 10. So 19 minus 11 if you do, you'll get 8 to the base 10. But what I really want answer as to the base 16. 8 to the base 10 as a decimal number can be written as 8 to the base 16 only in hexadecimal, right? Because from 0 to 9, decimal number and hexadecimal number are exactly same. After 9 only story changes. In hexadecimal what we get is a, and what we get in decimal is 10. So here I can write 8 now. Now the last subtraction is left, which is 9 to the base 16 minus 6 to the base 16. Converting 9 into decimal, which would be again 9 to the base 10. 6 to the base 16 can be written as 6 to the base 10. The subtraction is 3 to the base 10. But since it is decimal, let's get back to original number system. So as we know, 0 to 9 decimal and hexadecimal numbers are exactly same. So I can write this as 3 to the base 16. Finally what we have is 38 to the base 16. So the final answer, a3 to the base 16 minus 6b to the base 16 is 38 to the base 16. I'm sure you have understood all the problems. Thank you.